All right, so we're talking about polynomials, and we've discussed some of the characteristics of polynomials. In particular, we focused on end behavior and basically what the graph of a polynomial looks like. Here we're going to focus on zeros, x-intercepts, and multiplicity. So it says here, definition of a zero, if f is a function, then a zero is any value of x for which f of x equals 0. So basically, we're looking for the values of x that cause the function to equal 0. So next here it says, if f is a polynomial function and c is a real number, then each of the following statements are equivalent. Now I just want to make it clear, we've talked about what a zero is before here. I just wanted to make sure you're clear on what a zero is. And now we're going to see how these four statements really all tie together. And this is really important that you understand when you're working with polynomials. So it says on number 1 here, x equals c is a zero of f. And then you've got these three other statements that are all basically equivalent. So we're going to look at an example as we walk through this to help you see what's going on here. So in our example, we have f of x equals x squared minus 2x minus 8. And so our statement, number 1, would be x equals 4 is a zero of f. So let's go ahead and find the zeros by setting this function equal to 0. So we have f of x equals x squared minus 2x minus 8. We're going to set that equal to 0. Now this is a quadratic function, and we ought to be able to factor this. So we're looking for two numbers that multiply to, this is actually called the AC method. I just want to remind you here that let me change colors here. So here our A is 1, our B is negative 2, and our C is negative 8. And so what we need here is to find two numbers that multiply to negative 8 and add to negative 2. Now if you look at the factors of 8, you could use 1 and 8 or 2 and 4. Now because negative 8 is a negative number, we should have opposite signs here. Now the other thing is when we add the numbers, we should get a negative number. What that tells us is the bigger numbers should be negative. And so you can see that 2 plus negative 4 is going to be the numbers that work, because 2 times negative 4 is negative 8, and 2 plus negative 4 is negative 2. And so we're going to go ahead and factor this as x plus 2 times x minus 4. We set each of our factors equal to 0, and so we get negative 2 and 4 as solutions. And in fact, these are our zeros. And so we've confirmed that x equals 4 is a zero of f. Now in statement 2, it says x equals c is a solution or root of f of x equals 0. In our case, we're saying that x equals 4 is a solution of x squared minus 2x minus 8 equals 0. Well, in fact, when we were finding the zeros, we set the function equal to 0, and this is the equation we got. And so yes, 4 is a solution. That's what we found. Now, in 3 it says the point c comma 0 is an x-intercept on the graph of f. So if you look at our example, you have the point 4, 0 is an x-intercept of the graph of f. Now I've actually graphed this, and you can see that that's true right here. That is a 0. But I want you to think of, an x-intercept. I want you to think about how you find x-intercepts. Well, you let y equal 0, and that's what we've done basically here. F of x here is another name for y. We let y equal 0 here, and when we solved for x, one of our solutions was 4, which tells us that 4, 0 is an x-intercept. We also know that negative 2 comma 0 is an x-intercept, which you can see here. So basically, and this is really huge, when we have a 0, we essentially have an x-intercept as well. We have both. Or if I know an x-intercept on the graph, then I know a 0 for the function. These go hand in hand. And then finally, it says x minus c is a factor of f. Well, in our example, we're saying x minus 4 is a factor of f. So basically, when we found our zeros by solving this equation, you'll notice these two steps here. Well, actually, really, it goes it looks at all of what we did here. If you have zeros, going backwards, you can see that if negative 2 is a 0, that x plus 2 is a factor. And if 4 is a 0, then x minus 1 is a factor. So these go hand in hand. And so it's important that you understand that as well. All right, so let's go ahead and see how this works as we do some problems where we have to find zeros. All right, so it says find the zeros of each polynomial function and state the multiplicity of each. Now, on letter A, if I want to find the zeros, I'm going to need to factor this thing. But first I need to set the polynomial equal to 0. And you can see that all of our terms have a common factor of x, and so we're going to factor out an x. It's basically just doing the distributive property backwards. In fact, you could do the distributive property here to check yourself, and you'd get back to where you started. All right, and so now you can see here inside the parentheses, we have a quadratic function that we should be able to factor. I need two numbers that multiply to 9 and add to negative 6. Well, 1 and 9 and 3 times 3 are the only ways to multiply two numbers and get 9. And you'll notice that since these two numbers multiply to a positive 9, they must both be positive or both be negative. Well, since they need to add up to a negative number, they must both be negative. And so you can see the ones that work are negative 3 and negative 3. And so this factors as x minus 3 times x minus 3. And so you're going to have two zeros. And you can find them by setting your factors equal to 0. So x equals 0 or x minus 3 equals 0. We don't have anything to do with the x equals 0, but when we solve for x here, we get x equals 3. And so our zeros are 0 and 3. Now, there's something going on here that's a little bit different. Notice we have two factors of x minus 3. So I need to talk about multiplicity here. In fact, if you look at our directions, it says find the zeros and state the multiplicity of each. What do we mean by that? Well, here's a definition for you. The multiplicity of a zero is the number of times its corresponding factor occurs in the factored form of the function. So we've got it in factored form now, x times x minus 3 times x minus 3. Notice x minus 3 as a factor occurs twice, and so the 0 that corresponds to that is 3, and so 3 has a multiplicity of 2. So in our problem, x equals 0 has a multiplicity of 1 because there's only one factor of x, and 3 is a 0 of multiplicity 2 because that factor occurs twice in the factorization. So that's what we mean by multiplicity. It's really just a repeated 0. And in fact, notice this polynomial has a degree of 3, and if you count multiplicity, we have 3 zeros. That's an important thing to understand. All right, so let's move on to B. So here, when our polynomial is already factored, it makes it easy to identify our zeros. We know if x plus 3 is a factor, that 3 is going to be a 0. In fact, we can set x plus 3 equal to 0, and we can also do the same with x plus 1, and when we solve, we get our zeros, negative 3 and negative 1. But just remember what we just talked about on the previous slide. If x plus 3 is a factor, then negative 3 is going to be a 0. And if x plus 1 is a factor, then negative 1 is going to be a 0. So again, these things will always follow. If you got one, you've got the other. But you can see we can actually show the work to show that these are our zeros, just by setting our factors equal to 0. And in fact, if you plug in negative 3 here, once you get negative 3 plus 3 is 0, 0 squared is 0, and the whole polynomial is going to 0 out. And the same thing would happen if you put negative 1 here. And so it's very easy to see that these do 0 out the function. All right, what about our multiplicity? Well, notice x plus 3 is a factor that occurs twice, and so it has a multiplicity of 2. And our 0, negative 1, if you look at the corresponding factor, it occurs 3 times, and so negative 1 has a multiplicity of 3. All right, I would encourage you to try C. You're going to need to factor it, and then you're going to need to tell me the zeros and the multiplicity of each. All right, so in C, we're going to factor by grouping. So first let's set this polynomial equal to 0. And since we have 4 terms, we know we want to factor by grouping. So we'll group the first 2 terms and factor out the GCF. So you'll notice each of these 2 terms have a common factor of x squared. Oh, I messed that one up. Let's see, I should have a 2 here. So it'll be x squared times x minus 2. And now we know when we look at the other 2 terms, having some experience factoring by grouping, you're expecting to get the same factor that you got when you did the first 2 terms. So that kind of makes it a little bit easier to do this. And so now I just need to figure out what times x minus 2 gives me what I have here, and that would be a minus 9. And so we're going to have 2 terms, and you can see x minus 2 is the common factor. Now if you cross out the x minus 2's, you can see what we're left with is x squared minus 9. And so, boy, I have to change some things here because I made that mistake. So we have x minus 2 times x minus 3 times x plus 3 equals 0, which would indicate that our zeros are going to be 2, 3, and negative 3. Now notice this polynomial has a degree of 3, and in fact we got 3 zeros, and since none of our factors are repeated, we know that we're going to have a multiplicity of 1 for all 3 of these. All right, let's go ahead and move on to the next slide. Oh, let's see if I can do this. I'm going to have to skip a few things here. There we go. All right, so on number 13, it says find the zeros. Well, we know we want to set the polynomial equal to 0. And in fact, we did some like this in the last chapter. You might see if you remember how to factor this. And then you should be able to solve for x. Although it's a little bit different. Let's see. I can't recall if we actually did one exactly like this. So let's go ahead and look at it in detail here. So when I see this polynomial, it reminds me of, or I should say when I see this equation, it reminds me of this equation here, x squared plus 8x minus 33 equals 0. So this is a quadratic equation, and it looks like we might be able to factor this. So we need 2 numbers that multiply to negative 33 and add up to 8. And the numbers that work here are negative 3 and 11. Negative 3 times 11 is negative 33, and negative 3 plus 11 is 8. So when I factor this, I get x minus 3 times x plus 11 is equal to 0. And when we set those equal to 0, we get x equals 3 and negative 11. Now, this is actually not our problem, but it's quite similar. We're just going to do an adjustment. So let's go ahead and do that. So the difference is, instead of x and x, we're going to have x squared and x squared as our first terms here. And notice x squared times x squared does give you x to the fourth. And so now we're going to use the same numbers that we found before. It'll be x squared minus 3 and x squared plus 11. So it's just like the previous problem that I did, except for the x squared. Now we're going to do the same thing we did before, or we've done in the past. We're going to set each of our factors equal to 0. So we've got x squared minus 3 equals 0. I'm going to go ahead and add 3 to both sides, and I get x squared equals 3. And then we're going to want to take the square root of both sides to get x by itself. The opposite of squaring is taking square root. So when we do that, we end up with x equals plus or minus the square root of 3. Don't forget, when you take the square root of both sides, you've got to do that plus or minus thing. There's going to be two answers. So now let's solve x squared plus 11 equals 0. We'll subtract 11 from both sides, and we get x squared equals negative 11. Now I'm going to take the square root of both sides. Again, don't forget the plus or minus. And we know the square root of negative 11, that's going to be imaginary. We need to pull out an I. And so we're going to get x equals plus or minus I times the square root of 11. So in fact, we have 4 zeros here. We have x equals plus or minus the square root of 3 and plus or minus I times the square root of 11. And in fact, this polynomial has a degree of 4, and sure enough, we got 4 zeros. So finally, we're ready to make this statement here. A function f having a degree of n has at most n real zeros. The multiplicity of a zero is the number of times its corresponding factor appears in the factored form of f. We talked about multiplicity before. All right, so let's go ahead and move on to the next slide. And we're going to be finding behavior at real zeros, or x-intercepts. If the multiplicity of a zero is odd, the graph will cross the x-axis. If the multiplicity of a zero is even, the graph will bounce off the x-axis or be tangent to the x-axis, which is the wording they use in our current book. I'm going to go back to the previous slide, and I want to, actually it's a couple slides back. I want to show you for this function, this is actually the graph. And remember, we had at x equals 0, we had a multiplicity of 1, and notice we crossed there. At x equals 3, well, we had a multiplicity of 2, and notice at the corresponding x-intercept, which is at 3, 0, we bounced. The graph gets to that point. It doesn't cross, it just bounces back up. Let's see if that same kind of thing happens on part B. So on this one here, B is the graph above, right above it. We have x equals negative 3, which is a 0 of multiplicity 2. So if we look at the graph at negative 3, so that's the corresponding x-intercept is negative 3, 0. What's happening there? Well, the graph's bouncing. And again, notice we have an even multiplicity. And then finally, if you look at x equals negative 1, the multiplicity is 3, which is odd. And notice at that 0, we actually cross. And so what we are seeing here is if our 0 has a multiplicity that's odd, at the corresponding x-intercept on the graph, it's going to cross. The graph crosses at that intercept. If the multiplicity of our 0 is even, then when we look at the corresponding x-intercept on the graph, that's where the graph is going to bounce. All right, so let's go ahead and practice this. I need to go back to where I was before. Whoops, went too far. All right, so it says describe the behavior of the function's graph at its x-intercepts. All right, so let's look at A. So the first thing I want to do is find my zeros. And so we'll set the equation equal to 0. And I'm going to go ahead and factor. I need two numbers that multiply to 15 and add to -8. -3 and -5 are going to work. And so when you plug those in, you get x minus 3 times x minus 5 equals 0. And so we're going to get 3 and 5. So these are our zeros. So we're going to now make what I call a ZMB chart. And just let me tell you what each of these means. Z is for 0, M is for multiplicity, and B is for behavior. What's the behavior at the corresponding x-intercept? Remember, that's what we're supposed to do. Describe the behavior of the function's graph at its x-intercepts. So our zeros are 3 and 5. And they both have a multiplicity of 1 because each factor just occurs once. And now just keep in mind, if our 0 is 3, then the corresponding x-intercept is 3, 0. And because our multiplicity is odd, we would expect to cross at that point. In fact, it's going to be the same for both. If our 0 is 5, then at the point 5, 0, our corresponding x-intercept, the graph is going to cross. All right, I would encourage you to see if you can do the next two problems and then watch the video. All right, so here when we set this function equal to 0, you end up getting 9 and 9 that work, and so we have x plus 9 times x plus 9 equals 0, which means our 0 is x equals -9. There's only one. So let's do our ZMB chart, and we have 1, 0 of -9, which has a multiplicity of 2, which means at the point -9, 0, our x-intercept on the graph of this function, the behavior there, it's going to bounce because we're even. All right, on C, now notice if x minus 4 is a factor, then we know 4 is a 0. If x plus 6 is a factor, we know -6 is a 0. And so these are our two zeros. Let's go ahead and make our ZMB chart. Our zeros are 4 and -6. Let's see, the first one, the 4, let's see, the corresponding factor has a degree of 5, so the multiplicity is 5. And for -6, our multiplicity would be 8. And so so for x equals 4, at the corresponding x-intercept, because we have an odd multiplicity, we're going to cross. And at x equals -6, because our multiplicity is even, at the corresponding x-intercept, we're going to bounce. All right, we've got 3 more to do. And again, I would encourage you to try them first and then watch the video. All right, so on D, our zeros, now be careful here. There's actually 4. Sometimes students will miss one. Notice we have 4 variable factors here. If you set each of those equal to 0, then when you solve for x, you get your zeros. And so we have 4 zeros here. 0, -6, 7, and 2. Now 0, if you look at the corresponding factor x, it's to the first power, so that is going to have a multiplicity of 1. For -6, our multiplicity is 2. For 7, it's 4. And for 2, again, this is a 1 here as an exponent, and so our multiplicity is 1. And so at 0, on the graph of the corresponding x-intercept, we're going to cross. At -6, because we have an even multiplicity, we're going to bounce. At x equals 7 on the graph, because we're even multiplicity, we're going to bounce. And finally, at x equals 2, we have an odd multiplicity, so we're going to cross. All right, on letter E, you should have set that equal to 0 and then factored out an x. And then we can factor out the trinomial here. And you need two numbers that multiply to 4 and add to -4. And you'll see that -2 and -2 are what work. And so this is x times x minus 2 quantity squared. If you wanted to, you could write out 2x minus 2's. So you can see that our two zeros are 0 and 2. So if you make a ZMB chart, our zeros are 0 and 2. X equals 0 has a multiplicity of 1. X equals 2 has a multiplicity of 2. And so we're going to cross at 0, 0. And on the graph, you would bounce at the x-intercept 2, 0. All right, last one on f. When you set it equal to 0, you're going to want to factor by grouping since we have 4 terms here. You can factor out an x squared in the first 2 terms. It'll be x squared times x plus 3. And then you know that when you factor the second 2 terms, you can factor out an x plus 3. And you can see that negative 16 times x plus 3 will give us negative 16x minus 48. And so we can now look at each of the terms, and our common factor is x plus 3. If you cancel out those x plus 3's, you can see what's left is x squared minus 16. And so when we factor this, we end up with x plus 3 times x minus 4 times x plus 4, which makes our zeros negative 3, 4, and negative 4. When you do your ZMB chart, let's put in our zeros. They each have a multiplicity of 1, which means on the graph we're going to cross at each of those corresponding x-intercepts. All right, and that's it for this video.